Hi fellow enthusiasts, welcome back again to my channel. Please watch this video carefully. We're going to continue the episode we started 2 weeks ago, and this is on the basic electronics tutorial. So today we're going to look at a radio transmitter. So you will remember from last week this circuit diagram, we say that this portion here is the tank circuit or the resonance circuit, where we have an inductor and a capacitor. With these two in place, we can build a frequency determining network that helps us broadcast or transmit on this amplifier or this transmitter here. Now, how do you build a transmitter? To build a transmitter, you need an oscillator. To build an oscillator, you need an amplifier. So let me show you the basic diagram of an oscillator. An oscillator, you need an amplifier, and then you need what we call frequency determining network, FDN, and then you need what is called feedback network, F let's just call it FBN, feedback network. So this is the loop here. So you have an amplifier, take a portion of that through a frequency determining network, a portion of that through feedback network back into the amplifier. Obviously, you need a power supply unit. All right. So in our case, we have a new power supply unit that we unboxed last week. Now, what you need for an amplifier, we're gonna use a transistor amplifier. All right. So bias this transistor amplifier, and then we have a capacitor here. You can also use a resistor here. It doesn't have to be a capacitor. And then we have our power supply positive here, and this place is the ground for 0 volts. Now on the emitter circuit, you can also use a resistor. You can call this RE, or in our case we're going to call it maybe R2. You can also call it RE, emitter resistor. It's for temperature stability. Now I'm going to leave some space here because I want to use the same circuit diagram to design the entire system. So this will be an amplifier. I need to complete the biasing from the collector circuit. In this case, I'm going to use an inductor and the capacitor to create my frequency determining network. I'm going to use another capacitor here to take a portion of it back into my base, my emitter circuit as a feedback. So here we use 10 picofarads. Here I'm going to call it C. Here I'm going to call it L. Here I'm going to call it R1, C1. So let's just call it L1, and this will be C2, and this here will C3. We're going to take our antenna from the emitter circuit. We're going to call it C4. So then remember, for the power supply, you need a filtering circuit here, filtering network. So we're going to use a capacitor, 1 microfarad, and by let's say 16 volts or more. Our power supply is in this case about 3 volts. Remember, this capacitor must be as close to the transmitter as possible. If the power supply is connected from an external source like this, or maybe coming from a USB source, and you have some wires going from the power supply all the way to the transmitter, you want the capacitor to be the closest to the transmitter as it could be. We got this from KW Surplus. We're not advertising for them, but just telling you where we got it. Also, there's a Panasonic battery. You can use this kind of battery, AA batteries, for your system. But in our case, we're using the power supply unit that we purchased and we unboxed the other day. This power supply unit here, right? So you remember this, right? So we're not advertising for them, but it won't hurt to buy from them. All right, so that's the circuit diagram. So the C1 here, in our case, we use 103. 103, as you remember, is 103 is equivalent to 10 nanofarads. How to calculate that, if you want to check, is 10 times 10 raised to power 3 times, because it's a paper capacitor, the unit is in picofarad, 10 raised to power minus 12. So these 3 here will reduce minus 12 to minus 9. And minus 10 raised to the power minus 9 is nano. Therefore, 103 is equal to 10 nanofarads, right? So use those two in combination. We have only one transistor here, so let's just call it Q1. Now, I will not give you the value of L and C2, neither will I give you the value of C4, but I will teach you how to find it yourself. Because many of you ask me questions and say things like, how do I get this value? How do I know this value is the right value? So let me show you how to know the right value. So XC, which is the reactive capacitance, is 1 over 2 pi FC. If you know your frequency of operation and you know the value you want your XC to be, calculate C. So make C the subject of the formula such that C is equal to 1 over 2 pi FXC. In our case, for the antenna, you want it to be 50 ohms, XC to be 50 ohms. So substitute 50 ohms here, and you get the value for your C. All right, that's how you calculate that. Now for L1 and C2, for L1 and C2, how do you calculate that? For L1 and C2, and I'm referring to this inductor and capacitor in our resonance circuit. How do you calculate L1 and C2? To do that, remember that F0, which is fundamental frequency, is equal to 1 over 2 pi square root of LC. All right. So you know your F, target F, pick a value for L and calculate C, or pick a value for C and calculate L. That's how you do that. So don't let me, I don't want it to be limited to only the things I tell you. In terms of what components to use, I want you to be free to choose your own value. Choose your value for L. Choose this. Let's say you choose 21 microhenry, then calculate your C. Or you can choose your so C will be question mark, or you can say L is question mark, I don't know what it is, but my C is 10 picofarads, whatever, right? So do that and calculate and get your F. Now remember I said F is fundamental frequency, FO, so that means there's F1, there's F2. So at every multiple of the FO, you get another frequency, another signal being transmitted. So if you want to build this system, make sure you have a band pass filter. A band pass filter, or yeah, will filter out lower frequencies. So let me show you that. So let me draw this so you see me drawing it. So this is amplitude, and this is frequency. So your filter should allow certain lower frequencies. So this is from 0 to high, allow certain lower frequencies but cut off higher. They have another one that cuts off lower frequencies but allows higher, so that only this band is allowed. This is your band pass. All right. So your transmitter should be operating here, so you can cut off the lower and higher frequencies. So your FO will be here, F1 and all the Fs will be cut off. You just need this portion. So let's test this transmitter we've built. We built it based on the component that we tested last week using this awesome LC meter. Let's turn this on. So L is inductor and C is capacitor. We used this 2 weeks ago, sorry, to test these components, and they're really awesome components. So let's turn this on right now. We need a radio receiver for this, but we want to show you what is happening. So for that, we're going to use software defined radio, SDR radio, to test this out. So let me start that from the computer and you do that simulation for you. All right, let's see if it's loading up. All right. I want to sound a note of warning. In some countries, it is not legal to run a transmitter without a license. So make sure you have a license. In our own case, the 0. Let's say 0.037 watts. which is 37 milliwatts. So very low power. As long as you're operating at a very low power, it might be acceptable. But then you're doing it for a short period, and the range is so small, so it will not affect much in the area. But just make sure you have license, and make sure that your transmitter, your frequency is within the maybe the free band, so you can operate it without license. So make sure you if your transmitter is within the 27 megahertz band, you may not require a license, but verify. So this is the ISM band. uh, so in this range you don't require a license, but whatever country you are in, make sure that you're compliant with the law. So we build this circuit trying to get the SDR to run so we can test it for you. But the SDR is not coming, and so we might have to have a follow-up video where we show you the testing of this transmitter we built. Maybe part 2 later today. We're going to show you the testing of the SDR. Quick, the SDR is all right. Let's see. It's not responding, and unfortunately, you're not able to see it, so I can't uh, do much right now with this SDR. It's not responding. Okay, let's see. Come on. All right, let's do a follow-up video where we show you the function, the testing of the SDR. So let's do that. Let's split it into two. The next phase, we're going to talk about the SDR and the harmonics. We're going to talk about the SDR, the testing of this transmitter, and also the harmonics. All right, remember to like, share, subscribe, comment, and come back again in a couple of hours to watch the second part of this video. All right, I will see you in the next one. Please, until then, remain enthused.